Okie dokie, artichokes, let's get started. So this chapter is going to be a lot of games. You guys just played a game. We're going to play another game after this. But one of the main parts of this chapter is that you understand how you can move a shape, like this triangle, around the graph. Okay? So you've already played with these moves, and so now we're going to give them formal names. And then your next lesson is going to be in Minecraft, where you're going to learn the names and what they mean by practicing. So, first thing we're going to do is what the game, the key lock puzzles, was calling a slide. So you slide to the left, slide to the right. You know, take it back now, you know. You can also slide up and down. This is called a translation. And you're probably thinking, like translating a language? Kind of the same idea, right? If I translate a language, I take it from one language to the next language. In the same way, I might take my triangle from one side to the other side. A translation. Okay? Now, this right here is called transfer paper. It can also be made out of parchment paper. This I'm using is paper that you normally put between burger patties. Basically, all it does is allows us to see our shape. And we'll take a pencil, and we're going to trace our shape out onto our transfer paper. So if you take a look, my triangle now goes with me. Let's see if I can make that a little darker. You can make transfer paper at home, if you're not in the classroom to get some from me, out of parchment paper. Huh, that's not working at all, is it? Okay. One issue with transfer paper is that typically only pencil works on it. Sometimes, if you're lucky, pen and marker might, but I wasn't lucky today, so we'll have to watch my little ghost. So, for a translation, let's say I want to translate my triangle, let's say 6 units to the right. Okay? So I'm going to choose a point. It's very important. Choose one of the 3 points. I'm going to choose the bottom point here. We're going to watch that bottom point. We're going to move it over 1, 2, 3, 4, 5, 6. And that's where my triangle would end up, right? So if I want to redraw that, take my marker. It's not coming out. We'll take another marker. Maybe. Okay. Okay, really fast. 1, 2, 3, 4, 5, 6. Okay, awesome. That's exactly where my little triangle will end up. So I like to just peel this back, make sure I line up all my dots where they're supposed to be. Okay, and then I can redraw my triangle. Trace the lines. You don't have to be nearly as neat as me. You can go crazy without a ruler, but if you are like me and like things to be perfect, rulers are nice. Okay, so this meant that I translated 6 units to the right. Okay, let's translate in 2 parts this time. Let's go to the right 6 more units, and then we're going to go down 4. So we're going to take this, I'm going to focus on that bottom point again. 1, 2, 3, 4, 5, 6. Okay, I've moved it over 6 to the right. I'm now going to go down 4. Again, focusing on that bottom point. 1, 2, 3, 4. That's where my new triangle is. So we're going to peel it back. Make sure all of our dots line up to where they should be. And there we go. Oh, camera got out of focus. There you go. Okay, and we're going to redraw our triangle. Now you may be thinking, I thought, Miss Knock, that you moved this 6 units to the right. And I did, you watched me. But it looks like these 2 points are only 2 units away from each other. Sorry. My head keeps tricking the camera. But these 2 points are not the ones I moved, because if you take a look, this point is the same as this point. This point moved 1, 2, 3, 4, 5, 6. So really pay attention to what point you moved. They'll all move 6 points because they're all connected, right? But just because these look like they're 2 together does not mean that they are. So we moved 6, and then we moved down 4. Okay? That's a translation. You can slide side to side, you can slide up and down. Translations are pretty cool. So the next one we're going to do is called a rotation, which I think they actually just called it that on, what's the word? On the key lock puzzle. I think they just called that on the key lock puzzle. So a rotation is where you're going to rotate. Rotation, rotate. You know what? Just ignore my bad spelling. Rotation is where you move around in a circle around a certain point. Okay? So for this triangle, I'm going to move my triangle around the point 2, 1. No particular reason, just felt like it. Okay? So we're going to put a dot at 2, 1. And I'm going to rotate it 180 degrees. So what I like to do is I take the transfer paper, and around the point that I want to rotate it around, I'm going to make this plus sign, or crosshair if you play video games, okay? Then you're going to stick your pencil right on the point you're rotating, and you're going to turn your paper around that point, okay? Until the crosshair lines up again. So, first time the crosshair lines up again, that's 90 degrees. The second time it lines up again, that's 180, meaning that my new triangle is right here. So just like last time, we're gonna make sure all of our points line up. Okay, so my new triangle ended up way over here because I rotated it 180 degrees. Okay, 180 degrees. You guys might be familiar with 360 from if you skateboard at all, or do any kind of parkour, they'll be like 360, and you jump around in a circle and end up right where you are. A 180 is where you jump around and you end up facing the opposite direction, right? So it's a half turn. 360 is a full turn, 180 is a half turn, 90 is a quarter turn. So I moved my triangle 180 degrees around the point 2, 1. So I'll write that there so we remember that. So that's a rotation. The next one we're going to look at is called a reflection. I believe they called it a mirror in the key lock puzzles, which I keep forgetting the name of. I'm going to blame the fact that it's very early on a Wednesday morning that I'm doing this. So a reflection had this symbol in the key lock puzzles. A reflection is like a mirror, right? You're looking in a mirror and you see yourself. So the fun part about a reflection is that it's going to be equal but opposite. It's going to be the same triangle once we reflect it, but it's going to be opposite. Because if you look in a mirror, you're going to see yourself, right? But you're going to see yourself backwards. Like if you've ever looked in a mirror and you raised your right hand in the mirror, you raise your left hand. So it's going to be equal but opposite. So we are going to reflect our triangle here over the y-axis, which you'd recall is the up and down. When I reflect something, what I like to do is I like to draw a line over the thing I want to reflect it on. See, I have a line there. Okay. And then what I'm going to do is I'm going to take my triangle, I'm going to flip it, and line that line back up again. Voila! So we're going to... make sure all my dots are good again. They're all good. And then we're going to trace my triangle. And that is a reflection across the y-axis. Right? You'll see that my triangle is the exact same dimensions. There's everything the same about my triangle, except that it's flipped. It's now facing the opposite direction. That's how a reflection works. So this was reflected across the y-axis. Those are the 3 types of transformations that we've used so far. Now, in the Minecraft that you're going to do for the next week or so, there is a 3rd transformation. This transformation is called a dilation. If you've ever had to go to the eye doctor and have your eyes dilated, your pupils get huge, right? That's a dilation, because your pupils were tiny and then they got big. A dilation is also, let's say your pupils are big and they shrink when they're exposed to light. That's also a dilation. A dilation is a change in size. So for instance, if I did a dilation with this little triangle here, I would want to take all the points. Let's say I want to dilate it by 2, right? That means I want to double its size. So I'm going to take this guy here, multiply all the points by 2, and he's going to get bigger. I won't do it on here because I've run out of paper. We are going to have several lessons on dilations at the very end of this chapter. So in the Minecraft, you're just going to get to play around with them. Just some basic ideas. You'll take cubes, you'll make them bigger, you'll make them smaller, that kind of idea. Anyway, these are what we call rigid transformations because the triangle does not change in any way. It just kind of gets moved around a graph. If you have any questions on this, please ask me or Ms. Schmidt. Otherwise, enjoy your Minecraft world for the next week. Bye-bye!